Thanks a lot. Thank you. So I'll talk mainly about TransPod. So again, thanks Sven for the invitation. My name is Sebastian Gendron. I'm the CEO and co-founder of TransPod, so a Canadian company. We're based in Toronto, and we're developing what we know under the name of Hyperloop since 2015. So the company is almost 9 years old. We're developing the tech, and in parallel, we're developing a first potential infrastructure project in Alberta. So the vision is fairly simple. The goal initially is to better connect our cities, and with a system which is actually better than existing mode of transportation. And so the mission behind it is to develop this transportation system to be more efficient than cars, boats, airplanes, and existing trains. So this is the vehicle we're developing. This is the full-scale vehicle. So it's a size of a train coach or a bus. In basic words, and I like to use that tagline, it's an aircraft without wings. And for those who are not familiar with the concept, it consists of having vehicles like that traveling in a tube where you have removed most of the air. So it's a concept which is 120 years old as of today, and the basic idea is that if you want to go faster than high-speed train we have in Germany, you need to allow the vehicle to avoid aerodynamic friction. And so one guy back in 1910 said, you know what, why not removing most of the air? And then thanks to now electromagnetic propulsion system and levitation system, we can, in theory, achieve 1,000 kilometers per hour. So people may freak out and say, wow, this is crazy and so on. I just want to remind everyone that we already travel at that speed, and it's called an airplane. Okay, so we're not talking about science fiction, and I'll show you how, and in the next few slides. So and we've talked about that. Devils is in the details. Like at a really high level, it sounds like fairly simple, but you can easily end up into, I would say, an equation which doesn't make sense from an economical standpoint. When we started that with my co-founder, Ryan, so Ryan is the CTO, is our mad scientist. He developed our intellectual property. We analyzed why high-speed rail corridors, mainly in Europe, because this is where we've developed them first before, I would say, China, are not profitable. I don't know for Germany, but for example, in France, 80% of corridors don't make any money. And the basic, I would say, reason for that is that it's been a government decision to provide public service to citizens, which is, okay, good, but sometimes without looking really at the demand. And without looking at the demand, you can't really break even on the infrastructure, which is the main asset and the main cost. So that's the first item. And in order to do that, you need to have vehicles traveling, I would say, most of the day. And when you don't have enough demand with passengers, those vehicles actually can do both freight and passengers. So in a tube, because the vehicle is smaller, we're mixing freight vehicles and passenger vehicles like you have on an highway. You have trucks and cars. You can transport both, and because of that, you can make a better business case to finance those infrastructure. The second innovation, which I'll explain more in details, is not to use maglev. I mentioned that we're using propulsion and magnetic, I would say, levitations. So by default, for those who may be in the transportation sector, they'll say, okay, they're going to use a maglev system like it's done in China or Japan. The challenge with the maglev system, and it was actually pointed out by Musk in his document back in 2013, it's too expensive. It costs 5 times more than an high-speed rail line. So even if you can mix freight and passengers in a line, it's still not good enough. And so you must have, I would say, those magnetic systems on the vehicle to keep the infrastructure as simple as possible, which maglev doesn't do, because you have a split of the technology between the infrastructure and the vehicle. And this is what we've done at TransPod. It's to have all the tech on the vehicle, so you can keep the infrastructure cost at the similar level than an high-speed rail line and finance those infrastructure with private sector money. If you don't have that, forget it. And this is our competitive advantage. And going back to the devils being in the details, you're talking about three elements which are critical: the power transmission, how you transmit power on a continuous basis to those vehicles, the propulsion, and the levitation. Maglev combined all that together. At TransPod, we've decoupled those, and they're separate. Talking about AI, I'm not an expert. I've heard many things today, yesterday as well, and we position ourselves as a user, and we are looking carefully at what's been developed so far. And so we're already using AI like many of you do today, but it's more like we had a comment on an earlier talk about, checking legal agreements and speeding up things and saving cost on the day-to-day admin work. Fine. The next step, and this is what it's still challenging for us, and I'll give an example on the engineering side. We're looking at, for example, optimizing. There's a lot of optimization, like all over the place. But today, there's still not, in the AI world, the ability to actually propose solution to the level of expertise we're looking for. I know that this is coming. We're looking to work with companies who are interested to develop new models. But for example, on the nose of the vehicle, we're looking at optimizing it from an aerodynamic standpoint, And in order to do that, we could ask, an AI model to actually, what could be the optimum solution, having those kind of input like physical and technical input to the vehicle. And we don't have yet the necessary answer. We still need to go to experts in aerodynamics, and talking about complex problem here, the environment we are in is a non-continuous environment. So it's like being in high atmosphere, and the equations are non-linear. It's like there's lots of science and physics behind that, and we would be really interested to see how those equations could be populated to an AI, I would say, model, and to provide initial kind of solution, but meaningful solution. So far, we're still kind of going through the old school approach and going to professors in aerodynamics, experts in those specific fields, and there's not that many. The second, of course, application we're looking at is safety and reliability. And the basic application, and everyone is trying to do that too as well, is of course do predictive maintenance, especially on the infrastructure. A few words on the infrastructure. When I talk about it, it's a huge pipeline. So rather than transporting oil and gas, it's a steel tube and so on. But we foresee lots of maintenance on that, and also how AI can help us to be cost effective. So that's really kind of, again, that may be the one of the easiest, I would say, application moving forward, and maybe the closest. I may be wrong, but this is what we foresee so far. The last one is definitely about passenger comfort, personalized user experiences associated to our system. The last bullet point about AGI aided design or a higher comfort ride, I'll explain that. So the levitation system on our side is located at the top of the vehicle. So we're pulling up the vehicle rather than pushing from the bottom. And at high speed, it's really kind of with all the, I would say, discrepancies in the infrastructure. It's quite bumpy. It's like imagine driving with your car at 1,000 kilometers an hour. The dampening system won't be sufficient. So you need to anticipate those deviations and adapt the suspension mechanism to allow, I would say, a smooth ride. And this is also some IP we have behind that to make it, I would say, more comfortable than existing train and existing cars. and it's pretty neat. I'll explain a bit more down the road. Going back to the benefits and why we're developing that. Again, if it's not better to existing mode of transportation, this is pointless. And why do we believe that this is better than existing modes? First of all, and I'll put the speed at the end, okay, faster, that's gonna go quicker to another place, that's nice. But it's not the main, I would say, the primary, argument. The first one is to remove all the stress of any travelers. Is like, this is a tagline I like to use. This is to provide the frequency of the subway with the speed of the aircraft. Just project yourself as, okay, I can go to the stations. I don't care if I'm stuck in traffic. I know that, like for a subway, I'll have a vehicle every 2 minutes to go to my destinations. So that's the ultimate goal we have behind that. Then, so that's, of course, then there's all the environmental benefits behind that. It's electrically powered. We definitely must power this system with renewable energies. I know that you're in Germany. I would include nuclear power in that. So, and just to be kind of efficient as well. Talk about the convenience, and something people should know is that that system is way less noisy than a train or an aircraft. The reason why is that when you're traveling in a low pressure environment, sound doesn't propagate well in a vacuum environment. If you end up in space at some point, and I don't wish that for you, and you cry in space, nobody will hear you. And that's the same for the vehicle, is that as the vehicle travels in that tube, you won't hear it. There's a slightly sound when the vehicle passes by, but it's really negligible compared to an existing train. And last element, which is really key to implement those infrastructure, we're talking about elevated infrastructure. So it's the steel tube on concrete pillars. So when it comes to land acquisition, we don't want to cut any farmland in 2 pieces and having all those headaches with legal fight and so on. It's really to allow farmers to, I would say, continue to operate their farm as they do today, and same for the wildlife. So that's really what how we all the benefits we've identified associated to that. Where we are, we unveiled the first demonstrator in 2022. The team has been working like crazy on that. It's a scaled down model of the full scale you've just seen on the picture. And its weight, I would say, 1 ton. It's the size of a small car. And the goal of that demonstrator was really to develop those proof of concept for the levitation, the propulsion, and and power transmission. I'll get the video. I don't know if you can launch it too. Yeah, so you'll see that. So this is what we're working on in Toronto as of today. There's a half-scale vehicle, so that's the levitation system. The goal again, so just imagine, so it's not a full closed tube, but so we can see what's happening. This is the levitation system. So the hardware is fairly simple. We're talking about electromagnets, and we're keeping the gap. So before, and same with, this is the propulsion engines at the bottom. And it's a fully automated vehicle. There's no driver. At that speed, the human brain doesn't work as fast as it should. And so it's fully automated. And then this is what we've demonstrated to as well. What you don't see here is the power transmission. The power transmission, we realized that at a low pressure, the air is conducting electricity. So the arc you may see between the catenary and the cable on high-speed train, what Siemens or Alstom are trying to avoid because it's damaging the catenary and the cable, we're actually seeking that arc. So the power transmission, it's for some specialists, it's a similar, I would say, tech than what we can have on subway. Subway, it's a pickup chute touching a power rail. We still have the power rail and the electrode. We have an electrode on the vehicle, and we're transmitting so far on paper today. 6,000 DC volt and 700 amps. So it's really high voltage to be able to power that vehicle on a continuous basis along hundreds of kilometers. And the IP is available for those who are curious. If you go on Google patent, type TransPod, you will see. And anyway, if you want to dive into plasma physics and so on, this is where we are. And this is where, again, AI could help. But those are really specific fields where we just looking at the next stage of evolution of AI on how we can improve that. Construction to date, so this is a test facility in France. We aim to kick off construction this summer. And this is the project in Alberta. One advice we got from investors back in 2017, they're not worried about the tech. They said, you may have the best tech in the world, but if you don't have any market, forget it. And then, okay, fine. We went to the Alberta government, which is a western province of Canada, and said, okay, the deal is simple. Are you interested to work with us? And if yes, we are committed to bring private funding to the province. So the goal is we don't need public funding. We only need the government willing to work with us to develop this technology moving forward. And we broken down the project in 2 phases. The first one is a test track to connect the Edmonton airport to downtown Edmonton to mitigate the risk, to certify the technology, and as soon as it's certified, we'll have the green light to build the full the full line south to Calgary. One point you may have if there's investors in the room is that, okay guys, if the tech doesn't work, what do you do with that tube in the middle of nowhere? And what we propose with investors, this is how we can be creative on how to mitigate the financial risk. We propose a plan B. The plan B is easy, it's just to build a conventional railway line. So, of course, the ROI won't be as good as if it's TransPod, but at least the investor can recoup his investment and move forward. So this is how we structure that. And so back in 2022, if you go online and search a bit about TransPod, we secure $500 million to build that test track with the objective to start construction between next year and 2026. We're just in the middle of the admin work, securing the right-of-way, construction permit, infrastructure cost estimate, and public consultations. So this is the work we're currently doing. Other markets, the US with a potential line in Texas, Australia, and the Middle East. There's also some discussion in Saudi Arabia. I've learned as well to be more nuanced when it comes to oil and gas regions. Today, Texas and Alberta were pro, I would say, oil and gas and don't care as much as we want about climate change, are the one taking more risks than other regions, whether it's Europe or western part of Canada. And I've asked one person from Texas, okay, what's the reason why are you taking more risk than the others? And they said when it comes to finding oil, most of the time you don't find anything. So you better take a bit more risk to be at the forefront of innovation. And as of today, yeah, when it comes even to develop new system, if the business case makes sense, they are behind it. Now, just last slide as a conclusion. Again, going back to the vision, our objective is to develop a new network connecting cities. And we see this new technology, I would say, following the same, I would say, path as what the railway did, I would say, 200 years ago. Going back to a comment from an earlier talk as well, they said, okay, the pace of change is faster, so we may have more lines, transport lines, tube transportation lines, I would say, implemented faster than the railway industry did, I would say, 200 years ago. Having said that, where I'm more nuanced again, is that either more resistance now than 200 years ago, I don't know. So like there's more people, there's also, more like when it comes to implementing those lines and securing the right of way, this is challenging. To finish just maybe with the elephant in the room, this, and to give you a picture of where we are with the ecosystem, I have one main competitors who actually closed down last year. Another one in the US, which kind of not in good shape. Having said that, thanks to kind of Musk, who kind of push a bit the ecosystem, there's developments of that technology around the world. South Korea is developing this technology since 2011, and they're financed by the South Korean government. China is doing it. In India, ArcelorMittal, which is one of the major steel suppliers, is pushing for some development. In Turkey, Erdogan has an innovation committee, and one of the clusters is about tube transportation. In Germany, actually, you're doing quite well, but mainly at the academic level. In Munich, the University of Munich is doing a pretty good job. They have quite a bit of funding behind that. And also, more recently, I think it's in the former test track where Siemens developed the maglev line, is being repurposed in Dresden. Anyway, correct me if I'm wrong, with a company from Poland too as well. So anyway, and we are closing for a significant amount of, I would say, funding to fully develop the tech as we speak. So clearly our objective is to take the lead. Start with that first infrastructure project in Alberta, implement as much or use as much AI as we can moving forward. Anyway, thank you.